Lesson 5.1, Solving Inequalities by Addition and Subtraction. Our essential question says, how do you graph an inequality? Our new vocab word is inequality symbols. Inequality symbols should be a review for you. We have our less than symbol, kind of looks like an L, like your left hand gives you your less than symbol. And of course, our less than or equal to. Which means that it may be less than or it may be equal to. And then we have our greater than symbols. Greater than and greater than or equal to. And then one that we don't use all that often, but you should know, is just the not equal to. The not equal to symbol. So that would be when, like if x is not equal to 5, it could be anything else. It's just not 5. So that's an equal sign with a slash through it. Okay, let's shift over to talking about graphing. When you graph an inequality, you are graphing on a number line. How do you graph an inequality? How do you determine if you use an open or closed circle on your graph? And how do you determine which direction the ray is going? Well, when your variable is on the left-hand side, so if your variable is over here on the left of your symbol, there's a shortcut that you can use. If your number is less than or equal to something, like a boundary number, you are going to graph that with a closed circle, and the ray is going to be going to the left. So the reason it's a closed circle is because of this equal line underneath. That includes the boundary number, so that's why your circle has to be colored in. It includes the boundary number. So whenever you see an equal underneath your symbol, whether it's less than or equal to or greater than or equal to, you're going to have what we call a closed circle on your graph because you're including the number that circle is placed on, because it could be equal to that number or it could be less than it or greater than it. So less than, the numbers on a number line, if you look at a number line, the numbers get smaller to the left. So that's why the less than symbols have rays that are going to the left. If my x, my unknown, is something less than or equal to 2, I'm going to have a solid circle on that 2, and it's going to be anything to the left of that 2. Anything to the left of that 2. So less than or equal to. Another thing you might notice is that this little shortcut, if you look at the symbol, it actually matches the arrow, the direction of the arrow. So it can kind of help you out. So closed circle, and it points to the left. The symbol points to the left, so your ray points to the left. The only difference on this next one is it's going to be an open circle because it's just a less than. So less than, the numbers are less to the left, don't include the boundary number. The greater than symbols, this one's going to be closed because it's got the equal to underneath, and the greater than symbols point to the right for your rays because that is the direction where the numbers are greater. The numbers are greater. And again, notice that the symbol points in the direction that the arrow on the ray points. Symbol points the direction of your ray on every one of these. That is always true when your inequality is written with the variable on the left. So we are always going to switch them around. If they're on the wrong side, we're always going to have our variables on the left so that we can match the shortcut. Okay, graph each inequality. The first one says x is greater than -2. So I'm going to go with an open circle on -2. And greater than goes to the right. Make sure when you're graphing that we can tell which direction you've drawn your ray. So you've got to shade it in darker for us so that we can see it. Also make sure that your open circles are clearly open and your closed circles are clearly closed. So greater than, it was an open circle because it was just greater than -2, not including the -2. The next one is greater than or equal to 4. So I close my circle because it could be 4. And then it's going to go to the right. So that's what you could do for your graphs. The next ones I'm going to show you what some other students tend to like to do. It's less than 1, so it's open. Some students like to raise their ray up above like this. So there's no mistake in the direction that they're going. So either way, if you graph these, either way is fine. This bottom one, less than or equal to -3. So closed circle instead of open. It includes the boundary number of -3. Less than is to the left. Now we have some solving. So it says solve and graph. The first one, -10, is less than x minus 8. Then the second one, 7 is greater than or equal to x plus 11. Okay. To solve these, you solve them just like we solved one-step equations. So I need to isolate my variable. I can do that by adding 8 on both sides. So this is going to result in x, my inequality symbol, and -2. Now, my inequality is not written with the variable on the left, so I need to reverse it. I'm going to reverse the entire inequality. When you were in elementary school, you might have learned like the alligator eats the bigger number or something like that. You may have learned to look at like how the symbol opens, and it's opened up at the x. So if I want the x on the left-hand side, I just have to make sure that my symbol is still opened up at the x. So if -2 is less than x, that really means x is greater than -2. So greater than -2 is going to be an open circle, and greater than goes to the right. So there's my ray. My second example, I am going to subtract 11 on both sides. Bring down my x and my symbol. 7 minus 11 is -4. And now I need to reverse my inequality because the x is on the wrong side. This time, it's opened up at the -4. So I have to make sure it's still opened up at the -4. So this graph is going to be less than or equal to, so a solid circle or a closed circle, and then less than is to the left. So my ray goes to the left. You only do this reversing step if the variable's on the wrong side. So if the variable is on the right instead of the left. My next example, we're kind of covering a lot of different types of equations from chapter 2. Now we've got a variable on each side. My 4x is all by itself, so I'm going to leave that alone, and I am going to subtract the 3x on each side. So now I bring down my 1, and it's less than 1x. Some of you like to write out this next step where you divide by 1, and others understand that dividing by 1 just keeps your answer the same. 1x is the same as x. So you don't have to divide by 1 on both sides. You could just erase the 1 written in front of the x. Now I do need to reverse it because the x is on the wrong side. So my symbol, it's opened up at the x, so I'm going to keep it opened up at the x. So x is greater than 1. open circle, because there's not an equal underneath my symbol. Okay, the next one. 5x is greater than or equal to negative 2 plus 4x. I am going to leave the 5x alone because it's by itself on the left-hand side. Subtract away the 4x. So my result is 1x, which this time I'm just going to write it as x, is greater than or equal to negative 2. So I will have a closed circle on negative 2, and greater than goes to the right. So there's my ray. When you're reading problems that are dealing with inequalities, it's sometimes confusing to figure out what the words mean, which symbol they represent. So we are going to use this little table quite frequently throughout this chapter to make sure that you get the hang of it, okay? Less than, this is my less than symbol. My greater than symbol is next. Then I've got less than or equal to, and then greater than or equal to. Okay, now let's see what we've got next. More than, greater than would be more than. So that means that less than would be no more than. Let's think about that. Wow. If it's not more than something, is it less than it? Or is it less than or equal to it? So if I have no more than $10, I could have $10. I just don't have more than that. So I could have 10 or less. Okay, so then we've got fewer than. Fewer than would be less than. No less than. No less than. Well, if I do not have less than $10, I do not have less than, then I could have more than $10 or equal to. Okay? At most, if I have at the very most $20, at the very most, at the very most, I have $20. So then I could have, at the very most, I have $20. So I could have 20 or less. 20 or less. So less than or equal to. So here's another one. And if I have at least $20, then I'm going to have 20 at the very least. 20, 21, 22. So at the very least I have $20. That's going to be greater than or equal to. These are very tricky words to understand. I always try to connect them to money to help me out. Okay, use an inequality to solve this problem. Sam has $65 to spend at the mall. He bought a t-shirt for $18 and a belt for $14. If Sam wants a pair of jeans, how much can he spend? So, t-shirt, belt, jeans, he's looking to buy 3 things. And he's got $65. He doesn't have to spend it all, and he doesn't get to spend more than $65. That's all he's got. So the total for these 3 things that he wants to buy, his purchases, would have to be less than or equal to $65. He can't spend more than $65. He doesn't have it. Okay, now we know the t-shirt is 18. We know the belt is 14. We do not know about the jeans, so we are going to solve this inequality. I can combine the 2 like terms that are on the same side. 18 plus 14 is 32. And then I just need to do a little subtracting. So subtract that 32. So jeans have to be less than or equal to $33. So how much can he spend? He can spend up to $33 on jeans. Is my solution. Define a variable, write an inequality, and solve the problem. Okay, I'm going to use x to represent the number. That's the variable that I want. So twice a number. Twice means times 2. So twice a number, 2x. Decreased by 1, that means minus 1, is at least 17. Okay, the word at least, at the very least, 17. At the very least, 17. That means 17 is the lowest. So at the very least it's 17, it could be more. So my symbol is going to be greater than or equal to. Greater than or equal to. Because if it's at least 17, it could be 17. That's why I need the equal line underneath. It also could be more than 17. Okay, now my action steps. Add 1. You're probably thinking the solving piece is easier than figuring out that inequality symbol. That could be true. So add 1, divide by 2, two-step inequality, x is greater than or equal to 9. It's time to write your summary. And here are your homework problems.